So I just want to, there are two terms, energy modeling and energy analysis. There are multiple interpretations of what these two terms mean in the industry, but this is my take on it. The gist of it is, energy modeling is very complex. We typically don't want to do this architecturally. Energy analysis is very simple. This is something that we should do on every job. Okay? That's what I'm going to try to get at. So, but the results of energy modeling could be more accurate than energy analysis. And the reason for that is, as I mentioned, of the list of complexities that I told you, take for instance operations. Assuming that my building, school building, is a 12-year, is a 9-month operation, so that's one level of assumption, as opposed to figuring out exactly it starts at 8 o'clock in the morning and it goes to August 16th and there's a break for 12 days. So that's the other extreme of information that you want to put into. So for an energy modeling, that's how detailed you want to get into. But when it comes to energy analysis, you try to keep it at a surface level so that you can analyze this. Does that make sense, guys? So for energy modeling, there will be high levels of customization based on what the actual client wants. So you'll have to fine-tune your energy model to the nth extreme. So you don't want to do that on the energy analysis. It's just you're going to use standard, let's say, a school building. What is the standard for a school building in terms of operations, in terms of number of people, how much hot water they use? You're going to use standards for that. It could be slightly different from what your actual condition is. But to avoid complexity, we want to stick with standard templates.
The problem is our clients are going to interchange those two words.
They're going
to say, I'd like some energy modeling. They may very well mean I just want an energy analysis.
Right.
And if we take it to the literal, we're going to freak out.
Yep. So it's very important to understand what the difference is and not promise the one or the other to our client. So generally speaking, energy modeling will be more accurate. This is just give you an idea. Energy analysis will give you a range. And then expertise-wise, you probably need a high level of expertise because you're dealing with all kinds of systems that you don't typically deal with. And it often takes a lot of time.
Are we using the same program to do either?
Yep, I'll get to that in a second. We could. Oh, another important distinction. For all lead projects and for all projects that go after utility rebates, energy analysis will not make it because we won't be as accurate as these entities require us to be. So for lead or any energy rebates or incentives that we get from utilities, we have to go through this modeling. So it is important to understand that it is a time-consuming process and it will require a lot of fees.
Grim, can you qualify that? What you just said about lead, because you don't have to do modeling on all lead projects, right?
That is true.
You restrict on the number of points you get. But
Yes.
just because you have a lead project doesn't mean you have to model.
That's true. But typically, most projects do go after lead energy optimization points more than just the minimal points. Because the lead allows you to not do an energy model and just go by with meeting the standard codes to prove that your building is energy efficient. LEED allows you to do that. But typically, almost every project except for Stan's project, they've done energy modeling that I've worked on.
Hey, Trump.
Yeah.
Also for the utility incentives, APS, you can do the prescriptive measures, which is just an analysis,
Right.
versus a whole building
Right.
incentive, which requires a lot.
Right.
So
That's a good point too. And typically here in California, it's the same. You could do prescriptive or the custom approach, custom measures. But custom measures will probably get you the most money. Prescriptives are very restrictive. Okay? All right. So I just listed the list of tools that I can think of. There's so many out there, right? So most of these tools can do both. Some of these tools are good to do just energy analysis, and some of these tools are made for energy modeling. the two tools that our company signed up with, one is Ecotech and the other one is IESVE. Because at that time, when we signed up, these are the only two tools that seem to have some kind of promise. But what I'm going to talk about, well, I don't have the time, but Autodesk Vasari is something that has a lot of potential because it is inbuilt with Revit. And this is the program Trace that our engineers use and trust. There are all kinds of other programs, Energy Pro, Energy Plus, and eQuest. These are the three programs that are required for any California work. So you start to understand how many different tools we have to learn as a profession. Okay.
It's one.
Prem?
It's one.
Yeah.
Hey, Prem, would
Yeah.
you consider energy analysis a basic service and energy modeling an additional service?
Yes.
And then do we have guidelines for how to establish what to charge for energy modeling?
Yes, we do. And we have a database of that information. So I know we probably don't have the time for the quiz today, but this is one of the important sheets for today's discussion. So, we talked about these different ingredients that go into this mix to find your EUI, right? So, what is the most important thing to understand in energy analysis is of all these ingredients, in order to find the best of one of these ingredients, you have to keep everything else the same. It's very important to do that. And you also have to keep the tool the same. You can't keep changing the tool, right? So if you want to find out three different the difference between your wall systems, you want to make sure that you keep all the other items the same, so that you can find out, based on this example, envelope A is the best EUI. So can I take this information and go to my owner and say, between this, let's say envelope B is the standard code compliant wall, and envelope A is the super efficient ICF wall, for instance. Can I take these two numbers during early programmatic design or schematic design and go and tell my client that I'm going to save 7 kilo-BTUs per square feet for your building, which translates into $10,000 a year? Can you say that?
No.
No. And please don't say that, because it is not accurate. Remember, we talked about all these other assumptions, all these different complexities. We're taking energy analysis as our path. We're not doing energy modeling. Energy analysis is to give you an idea or ballpark information of where you want to go. So just use this information to inform design, because there's also other items, cost, schedule, and program, that are important to design. So use this information as part of your analysis factors, not the only factor. Good? So